In this last problem, suppose you take out a loan at 1% per month. You make monthly payments of P dollars. What is the minimum required payment so that you can pay off a loan of $10,000? Okay, so first of all, the thing that we should notice is that if we're being charged interest and we're making a payment, if the amount of interest that we're being incurred, or it's being incurred on our account, is greater than the payment that we're making, our loan balance is going to go up. But if our loan interest amount is smaller than our payment, then our balance will go down. So let's draw our black box model here just to see that this is another bathtub analogy problem. So we have our balance in here, which we'll just say y equals loan balance, be measured in dollars, and t will be time, since you took out the loan, measured in months. Since we're in months, we're going to stay in months. If you want to convert to years, you can convert to years, but not necessary. So y of 0, the balance at time 0, is $10,000. And what we have coming in is 1% interest. 1% is always being taken off of your loan balance. So 1% of whatever your loan balance is how much the bank will charge you. So the first month, 1% of 10,000 is going to be 100. And so if that's the case, then that means I'm going to have $100 of interest in my first month. Now what's coming out is I'm going to be paying this thing off. I'm going to be draining this balance tub at a rate of P dollars per month. And notice that our units here have to be in dollars per month. So dy dt will be the rate in minus the rate out. And once again, we'll solve this. So see if you agree with me here, and go ahead and work this off to the side, or go ahead and pause the video and do this on your own. But here's the integral that we'll ultimately have to take care of. And once we do that, I'll just go ahead and do this in my head, but I think we're going to come out with 100 times the natural log of 0.01y minus p equals t plus c. And when you divide by 100, you'll have, let's see, y equals, this will be k e to the 0.01t. And let's see, then we'll add p and divide by 0.01. So we'll have plus p divided by 0.01. Plugging in our initial condition, we should get that k is equal to 10,000 minus p over 0.01. Again, I'll let you work through those details. But here we have, finally, y equals 10,000 minus p over 0.01 e to the 0.01t plus p over 0.01. And now we're ready to analyze the model. So we want to know what's the lowest payment that we have to make in order to pay this balance off. All right, so we'll go ahead and insert that slider for P. We're talking payments here, so it doesn't make sense to make less than a $0 payment. And I'm going to go all the way up to maybe $500 payment. It's a $10,000 loan. You can't be making payments of more than $500 a month on something like that. All right, let's go ahead and see. So our initial balance we know is up here at 10,000. So I'm going to have to set my balance higher than that just to be able to see the curve. And what we have going on here is, well, if I make a $1 a month payment, then my balance is just going to continue to soar. I'm not making payments to keep up with the interest alone. So this is what we often call a reverse amortization, which means that instead of reducing the balance, I'm increasing it. And as we increase this payment, we should see that our balance is still increasing because I'm not making a big enough payment yet. But eventually, if I make a big enough payment, oh, look at that, $100. If I make a $100 payment, my balance will never change. Well, that must mean that the interest on $10,000 is $100. And if I'm paying $100 and they're charging me $100, then I'm never changing the balance. And that's not good either, right? But if I change this to $101 or $103, you can see that over time, and it takes a long, long time, in that case, I'll be paying this loan off for 354 months, which is almost a 30-year loan of $10,000. That's excessively large. But you can see what happens if I make payments of close to $500. I can get that balance paid off in about 22 months. If I make it closer to $300, let's say, then it's going to take me about 41 months to pay off. But if I make that payment equal to 100, notice that at p equals 100, the function goes from increasing to non-increasing, non-decreasing to decreasing. That's going to be something we're going to keep in mind as we move forward in our study of differential equations. So there we go. So this is our time in months, and this is our balance in dollars. And we'll just go ahead and end this by saying a payment of anything greater than p equals $100 per month will allow the balance to ultimately be paid off. So in this video, to recap, we've looked at some tank problems, we've worked with the bathtub analogy some more, and we've begun to look at parameterizing our models to conduct more robust, powerful analyses. In the next lesson, we will get into how could we have solved some of these questions a little bit more simply using some other techniques.